Hello friends, welcome to Risingpearl.com. Today we are going to take a look at question number 18 that appeared in 2016 CBSE Class-X Math exam, and how do we actually solve this question. So let's take a look at the question first. A sphere with a certain diameter of 12 centimeter is dropped in a right circular cylindrical vessel which is partly filled with water. So we have a sphere and we drop the sphere in a cylindrical vessel. The vessel is partly filled with water to begin with. If the sphere is completely submerged in the water, so once we have dropped the sphere is completely submerged in the water level in the cylindrical vessel rises by a certain amount. So it means that, remember, the cylindrical vessel already has some water. When we drop the sphere into the cylinder, the water level rises by a certain amount. And this is the amount by which the water level rises. Find out the diameter of the cylindrical vessel. So again, like the last question we saw, there are no shapes or diagrams given. So we are going to draw a diagram for ourselves. So what is that we have to do? We have a sphere. Let's draw a sphere. Now, what is the one and only one measure which is very important for sphere? That is the radius. Is this radius given to us? The diameter is 12 centimeter. We know that diameter is 2r, so if that is equal to 12, from here we can say the radius will be 12 by 2 or 6. So yes, the radius is given to us. This is 6. Now we also have a cylinder. Let's draw a cylinder. So at this point we have this cylinder. This is actually partly filled with water. Now we do not know how much of this is actually filled with water. So let's assume that this is filled with water till certain height. So this is filled, so this cylinder is filled with water till here. So now what are we doing? Before that, now is anything else given about the cylinder? Nothing else is given about the cylinder. Now what happens is we drop the sphere into the cylinder. So what happens then? So it will look something like this, right? Because we have taken the sphere and we have put it inside the cylinder. So the sphere goes in, and what is given is that the water level, which it has some water earlier, the level rises and the sphere is completely submerged. So let's say the water level goes till here. After we drop this sphere, the water level has gone till here, right? Now at this point this is all what is given. Also what is given is that now this is the new height of the water level and this was the original height. This difference by which the water level has increased, this is given as, let's write this difference as h, is given as 3/59. This much centimeter. So, and what we have to find out is we have to find out the radius of the cylinder. Actually not the radius, we have to find out the diameter. But diameter is twice radius, so first we have to find out the radius of the cylinder. So how are we going to go ahead and solve this question? So let's first look at now what we have. So we have water level at a certain amount, right? And let's say initially the water level was somewhere over here. Now this change in the water level, why did this happen? Because the amount of water, we did not take out water from inside the cylinder. So what really happened was the cylinder was dropped into the sphere was dropped into the cylinder and the water level rose. So this band that I am trying to highlight over here, this band, this must be caused by the sphere. The change in the height must be caused by one and only one factor, which is the sphere. So if we find out the volume of this band, and remember this is a three-dimensional shape, right? Because it is this height all around the cylinder, right? So that amount must be equal to the volume of the sphere itself, because that is, the sphere is causing the water level to go up. So the increment must be because of the sphere. So the volume which is in here, which is the difference in the height, so this entire volume must be equal to the volume of the sphere. So what is the volume of this amount? So if we assume the radius is r and this height is h, then this volume will be equal to pi r square h, and this must be equal to the volume of a sphere. Now we know the formula for volume of a sphere is 4 by 3 pi r cubed. Clearly this r is the cylinder and this is for the sphere, right? So in other words, so this will be equal to pi times, we don't know r, so let's call this as r square, and this height is given as, this is given as 99359, or this will be 9 3 is 27 plus 5 32 by 9. So let's change the height h by 32 by 9. 32 by 9 equal to, this will be 4 by 3 pi r, we saw that r is equal to 6 cube. This is the radius of the sphere. Now if we solve it, so pi and pi will cancel out, or what we have is r square will be equal to, now let's write the things here properly. So 4 times 6 cube is 6 times 6 times 6 divided by 3 times, now cross multiplication, so this will come here 32, and 9 will go in the numerator over here, right? So if we look at this, so we will have now 3 1s are 3, 3 2s are 6, right? Now 2 1s are 2, 2 16s are 32, 4 1s are 4, 4 4s are 16. So we have, so 6 square, we have 2 6s, 6 square times 9 can be written as 3 square and 4 can be written as 2 square. So r square is equal to this. So if r square is equal to this, then we can say from here that r, we are just writing this here, so r will be equal to, if you take a square root of this, the entire thing, it will be 6 times 3 times 2, and 2 3s are 6, so r is going to be equal to 3 3s are 9 centimeter. All the units are in centimeter. We have to find out the diameter, and please do not overlook this factor. We are not looking to find out the radius of the cylinder, instead we are looking to find out the diameter. So if r is equal to 9, that means diameter, let's write it probably over here, diameter will be equals 2 times r, 2 times 9, or equal to 18 centimeter. So the diameter of the cylinder will be equal to 18 centimeter. This is how we solve question number 18.